Welcome to CAD, Computer Aided Design, that's what it stands for. Today I'm going to be showing you how I made the jet. So you may see the jet and be a bit intimidated by it because it's a bit complex, but it's quite simple. Once you get enough experience, it should be very simple. So I started with is a circle, a sketch. A sketch is a drawing on a two-dimension plane. So what I did is I drew a circle with a dimension 110 millimeters. Then from there, I used the extrude function to create a body out of it, a block you could say. So the extrude function basically takes the 2D face, moves it in one direction only. So it's a straight line, as you can see. And I chamfered it. Chamfer basically means it makes a nice sharp, it makes the nice sharp edge into a more, it's a like slope. So this one, it's not an angle. This one, it can be an equal distance chamfer, a two distance chamfer, or a distance and angle chamfer. I use the two distance chamfer because it's more, I prefer that. So I went 40 millimeters in and 50 millimeters out. So from there, I just started building the body. The body may look a bit complex right now. If you look at front view, it's a bit intimidating. But it's actually very simple. What I did was I drew a sketch. And you can see the sketch right now. It's just a rectangle, and I pulled it out using the extrude function. And then how did I get that nice like curve between it? The solution is using a fillet. A fillet essentially is it'll make a curve between two faces on one edge. So I simply selected this edge, these four edges, and then I did a 75 millimeter chamfer, which means the chamfer, sorry, not chamfer, the fillet. The fillet has a 75 millimeter diameter, which gives me this very nice curve. And then from there, I just continued. And you may be wondering how I made the wing. The wing is very simple, so I shall show you. Well, first thing you do is you create a sketch. A sketch being on the 2D plane once again. So I make an aerofoil shape on the plane, whichever kind of plane you want, the 2D plane or the actual plane, you know. Anyways, you can ignore the straight line through the middle. That's just what I used to calculate wing area. And what I did was I copied it and pasted it. And when I paste it, I cannot have an option to move it around. So I moved it out. And then after that, I scaled it down. And then I have two drawings, two faces. What do I do from there? I just loft them together. A loft basically combines two faces into the smoothest possible shape. So when you have two identical shapes, one smaller than the other, and you loft them together, essentially you get a tapered look, which is what I was aiming for. So that's how I get my tapered wing. And then here is a sweep. A sweep is similar to what's it called? Extrude, right? But instead of extruding in one direction only in a straight line, you can choose a path it will take. So this path goes straight and then curves up, as you can see. And then there's the chamfer here. The chamfer essentially what it does is wait, I've showed you this already, never mind. But yeah, you can see I did a chamfer here as well. And then I did more lofts here. This loft is just to smooth blend this little edge here. One sec. What I did was I just blended this edge, this little like this cut off into the body. That's what I did. So it looks smooth. And here's a revolve function. What it does basically is I take a sketch and I use a revolve. So I choose which axis I want it to revolve around. In this case, I want it to be this axis, the straight line. So it will revolve around that straight line and give me this. And then after that, for the cockpit, I used another sweep, this one. You'll see it. I sweep it along the path. And then for the wing, I did more lofts, the main wing. The main wing has some complicated parts going on in it. So essentially, I'll walk you through the process as to how I created two separate wings. I mean, a wing that's the same shape, but two separate bodies with the aileron here, which controls the plane's movement, as well as the wing itself. So how I did it was essentially I lofted the wing I lofted the two faces together to create the wing. Oh, give it a sec. Okay, there you go. It's saying there's failure, but really there's no failure, it's fine. But essentially what I did is I created the loft, and then after that I extended it out, and then from that I cut away the body of the loft that I wanted to, the part that I wanted to cut away. After I created it back, but as a different body, and then I just shrank it back. It's a bit complicated, but I perfected the process of creating a wing with an aileron in it. There are also things called offset faces. Basically, you take a face and then offset it inwards. Also, it keeps the shape, but it changes the dimension a bit. So this one went in by 0.3 millimeters. And that's about, oh yes, here, copy paste bodies. I just simply copy pasted a body, moved it up, as you can see here, because I needed to cut away the wing and then, I mean the tail, and then after that reconnect the tail as a separate piece. So what I did is I copy pasted the body, moved it up, cut away the tail, intersected the tail, intersection meaning this one. I, I just cut away everything except the tail basically, and I moved the tail back down. And then I used the mirror function to mirror my wing, my aileron, and my elevator, which is the rear wing. Also, usually when you draw something, to make it more efficient, you'll draw half the body and then mirror it over. But the reason why I didn't do it for the body this time was because if you look at the start, it's actually, I forgot to show you this as one of the more cool things, is because there is no symmetrical parts in this one. You can see. You may be wondering, what's this L shape? This is a twisting lock. Essentially what I do is I push it in, twist it, and it locks into place. Like this, it locks into the this little piece here, and there'll be an outer piece, if you can see, like that. So actually, if I go slightly forward, I can actually go to the body, uh, opacity control 50%. So you can see the body sort of, and you can see if I twist it, if I twist this body, this engine mount as I call it, you'll see it unlock, and I can pull it out. But then once I twist it, it locks in. So yeah, that's how I designed this plane. That's the reason why I didn't use the mirror function. Also, this is called a history. This is called a timeline. Essentially, what you can do is you can go back in the past, change things, and then go back to the future. I mean, the present, without changing what you did in the present. So, example is I did this. Example is I did this sweep. I go back, I change something in the past, and then I move it back. It does not affect the sweep at all, unless they intersect each other or they interrupt each other. In that case, it will affect it. But yeah. And if you take a look carefully, there's a section analysis where I cut it in half, but it doesn't actually cut it, it just shows me the half view. So you can see I'm hollowed it out here to affect the center of gravity, so there's further setback. I have a compartment for my electronics, a hole here so the wire can run through, and also the air intake here for the fan. And there are other things under the inspect one, such as measure, interference. Interference essentially shows me whether two bodies are touching each other or not. In this case, you can see no interference is detected. However, this, however, example would be if I move this forward, if I move it into each other, obviously they're touching each other. If you use the interference tool, it will tell you so. So compute, it will tell you how much surface area is touching each other and where. So you can see right now, it is not supposed to turn white. It has that error sometimes, but I can't be bothered. You just have to restart the Fusion 360. So you can see they're touching each other. The red part is where they're touching each other. So yeah. And also things such as zebra analysis, which really just shows me the curvatures of the body. You can see how it curves here. And then there's also different kinds of curvature analysis, and of course there's a center of mass, which is my favorite one when it comes to actually you can see the center of mass right now. It's this one right there. Because the center of mass and the center of lift is crucial to making a plane stable. Unfortunately, it does not compute center of lift for you in Fusion 360 because that is meant for regular 3D design, not specifically aerodynamics. You need paid software to do that, so I'm just gonna wing it and test it out. Well, this is just the basics of AutoCAD. There are a lot more other features such as like derive. I have no idea what that is. Oh yeah, so what you're used to is creating a box, cylinder, sphere, or whatever, using preset designs in what's it called? I forgot what it's called, but yeah, I was introduced to the same thing. But now you can just create any kind of shape you want using the create sketch function and then extruding it out is much more efficient. So it's not efficient, but it's more, you can tailor it to what you need it to look like. So yeah, it's very cool.